Hello, good morning all. So today we are going to discuss variable length records. In the last class, we had a discussion about fixed length records. We have started unit number 4 and we talked about fixed length records. So in fixed length records, all the records require same amount of memory to store the record. Whereas in variable length records, the size of the individual record in a relation may differ. In fixed length records, all the records belonging to one relation have fixed size, whereas in variable length records, each record may have different size, even though the records belong to the same relation. So what are the possible reasons why we are having variable length records? The very first reason why we are having variable length records in the same relation is storage of multiple record types in a file. So it is possible that we may have several different record types. Those are stored in a file. Meaning, if we are referring to our university database, then it may happen that two different relations, say department and instructor. So obviously size of department record is different than size of instructor record. And if it happens that these two records of two different kinds are stored in a single file, then obviously we are having variable length records. Those are stored in a single file. So that is one reason. Secondly, record types that allow variable lengths for one or more fields may result in variable length records. For example, if I am having instructor table and if the instructor record is described, say with ID, 4 attributes: ID, name of the instructor, then department name of the instructor and salary of the instructor. Let us assume that this ID is of type varchar, say 5. Name is also of type varchar, say 25. Department name is also of type varchar, say 20, and salary is numeric, say 8, 2. So if this is my instructor record, right? Now if we look at these three attributes, ID, name and department name, these three attributes are of type varchar, meaning this ID requires maximum 5 characters, right? This name requires maximum 25 characters to store, but as it is mentioned as varchar, it is variable. It is possible to store variable length strings in this particular attribute. Meaning, if name is, say, Ram, then the number of characters actually are utilized to store this name are 3 characters, right? Even though the maximum size for name is 25. It is not the case like all 25 bytes are allocated to store the name. Whatever may be the actual size of name, only those many characters will be utilized if the data type for the attribute is varchar, right? So this is the difference actually between char type and varchar type. So earlier whenever we discussed fixed length records, we used data type as char, meaning if I am having declared the attribute of char type with maximum size 25, then it does not matter that actually how many characters are there while storing the value for the name for a particular record. Even though the name actually contains 3 characters, all 25 characters will be utilized in char type. But in varchar, if my name value is requiring only 3 characters, then only 3 characters will be allocated, right? So I hope you must have understood what we mean by the variable length strings, right? And what is the varchar data type. So as there are 3 records, or rather 3 attributes, those are of varchar type. Actually those are utilizing the number of characters those are actually needed to store the value of those attributes for the particular record. Whereas this attribute salary requires 8 bytes of memory. It is fixed, right? So this is also one more reason, because the record types are allowing variable length attributes, right? The size of the record is different depending on actual values those are stored in the respective records, right? So this is the second reason why we are having variable length records. The third reason is record types that allow repeating fields. So what we mean by the record types, those allow the repeating fields such as arrays or multi-sets. Meaning if I am having say student data that I want to store, I am having ID of the student and I want to store the courses, those are opted by the student. So it is possible that I may prefer to store the data like ID of the student is 101 and the courses those are opted by this particular student 101 can be stored in a single attribute courses in the form of a set. Say for example, CS 101 is the course opted by this ID, the student. CS 105 is another course. CS 111 is one more course. So this student with ID 101 has opted for 3 courses, whereas suppose I am having another student say 151, ID is 151, and if he has opted for only 101 and CS 105, then obviously the size of this particular record and size for this particular record is different, because this attribute courses is actually allowing to store the multi-sets or the set of values. So depending on the number of values we are storing, the size may alter. So this is one more reason why we are having variable length records. So once again, I'll be summarizing. The first reason is we may store the records from 2 different relations in a single file. Secondly, the record types allow variable lengths of one or more attributes that we are storing. And third is record types that allow multi-sets or repeating fields to be stored under one attribute, right? So these are the possible reasons why we are having the variable length records. So let's see now what are the techniques to store variable length records. But while discussing techniques to store variable length records, we need to consider two important issues. Those need to be addressed by these techniques. So the first issue is regarding efficient extraction of individual attribute of the record. So actually the record comprises of multiple attributes, right? So in a single record we are having multiple attribute values stored. So we need to have a technique such that it represents a single record in such a way that individual attributes can be extracted easily. The second issue that the technique needs to address is regarding extraction of entire record. So the records are actually stored in blocks, right? So the technique should be like whenever a variable length record is being stored in a block, the record from the block need to be extracted efficiently or easily. So the technique need to take care of this also. So two important points: how to extract attribute easily and how to extract entire record easily. So that needs to be taken care of by the techniques those we are talking about, right? Now let us proceed to actually the representation of variable length records. So see here, let us assume that we are having the instructor record, and this instructor record is having 4 attributes, right? So instructor record comprises of 4 attributes: ID, which is of type varchar; name, once again, which is of type varchar; department name varchar; and salary numeric, right? So as we have seen earlier, this varchar type actually uses the number of characters those are actually required to store the value of that attribute, right? So say for example, if I am having the name Ram and if I am having the name Ram Prasad, then the maximum characters those can be stored under name as varchar attribute is 20. Maximum number is 20. But if I am storing the value of name for a particular record as Ram, only 3 characters are utilized, and if I am storing the name Ram Prasad, then 9 characters are being utilized, right? So only those many characters or that much memory space is being allocated by making use of varchar, and this is one of the reasons that we are having the variable length records. Now if we want to store this variable length record, see here the representation on this slide. So this figure actually shows an instructor record whose first 3 attributes are ID, name and department name, and these are of type variable length. So these are varchar, means these are variable length strings, right? And the 4th attribute is salary, which is numeric and requires say 8 bytes of memory to store this number. Okay, so see here how actually we are storing this data, this record, right? So here we are having few entries like offset length, right? So as we are having here 3 variable length records, we are having these pairs of offset length for 3 attributes. Those are variable length attributes. Okay, so the first variable length attribute is ID. So for this ID we are having this offset 21 and length. That means the length or the bytes actually required by that value that we are going to store, right? So see here for this ID we are having offset as 21 and 5 is the number of bytes those are required to store this value of ID. So meaning this attribute ID value is being stored at this offset 21. See here, this is 21 and next 5 bytes 21 onwards, next 5 bytes are utilized to store the value 10101. Right? Now here we are assuming that to store offset and length itself we require 4 bytes. 4 bytes to store offset and length. So offset requires 2 bytes and length requires 2 bytes. So for these variable length attributes to store offset and length for these attributes we are requiring 4 bytes. So first 4 bytes, that means 0 to 4, first 4 bytes are utilized to store offset and length for this attribute ID, first attribute. Next, second attribute is name. The value stored for this name in this particular record is Srinivasan. So the characters required to store this value Srinivasan is 10 characters, right? So from 26 onwards, next 10 bytes are utilized to store this Srinivasan value of attribute name. So offset length pair here is stored for name in from byte number 4 to 7, 4 bytes. So 26 is the offset where we can find the value for attribute name and the size of that attribute value is 10 bytes. That is what is represented using this offset and length. So whenever we jump to this 26th byte, we find this attribute value name here. So next 10 characters are being utilized, 10 bytes are being utilized to store that name. Further, the third varchar attribute is department name. So here this offset length parameters are meant for department name. So from byte number 36 onwards we are storing the department name, and to store department name we are requiring 10 bytes because size of department name comp science is 10 bytes. So offset is 36, meaning from 36 byte onwards we are storing 10 character or 10 byte value of department name, that is computer science. Right? Now the fourth attribute is salary, which is numeric, and as I stated it requires 8 bytes which is fixed. So see here for these three attributes 4 4 4, that means 12 bytes are utilized to store offset and length. So from 12th byte onwards next 8 bytes are utilized to store actually the value for salary. Okay, now the next component that we have stored here in this record is the null bitmap. So let me tell you what is meaning of this null bitmap. Since the record has 4 attributes, the null bitmap for this record fits in 1 byte. Although more bytes may be required with more attributes, right? So the null bitmap is stored here after this offset and the fixed length attribute. In few of the representations this null bitmap is stored initially. Okay, so it depends on the representation. So what we are storing in this null bitmap? So this null bitmap represents the bits either 0 or 1. As we are having 4 attributes, we are having in null bitmap 4 bits. So every bit represents whether the respective value of the attribute is null or not. Here in this particular record, we are having all the values available. For ID, we are having value 10101, for name Srinivasan, for department name Computer Science, and for salary 65,000. So none of the attributes are null, and that is why we are not having any one in this null bitmap. If it happens that I am having this salary value that is null, then the fourth bit of this null bitmap will be set to 1 if my salary is null. Right? So this is how we should represent this null bitmap. Okay? So this is the representation of a variable length record. So this representation is particularly useful for certain applications where records have a large number of fields, right? And this null bitmap is typically useful if the large number of attributes are there in the record and many of the attributes are having the null value stored. So in that situation, this null bitmap is more useful, right? So I hope you must have understood the concept. Now we have seen how individual record with variable length is being stored in memory, right? So how the attributes are being stored, how the offset and length is being maintained, right? So we have seen representation of individual record. Now actually we are having lots of such variable length records, and those we need to store in a disk block. So let us see now the slotted page structure that is being used to store such variable length records in a block, right? So the actual records are allocated contiguously in the block starting from end of the block. So see here, whatever you are visualizing right now on screen, right? So this is one block, okay, and several variable length records are being stored in one block, right? So this slotted page structure technique is commonly used for organizing records within a single block. So you must be knowing that we are having a file, right? And one file may have several blocks, right? So in every block we are storing the records. So right now we are seeing how in a single block multiple variable length records are being stored, right? So for this block, or this is known as the slotted page structure, we are having a header, right? And this header contains number of record entries. See here, number of record entries. Then this also stores end of free space in the block, end of free space in the block, and this stores location and size of each record, right? So this block header also stores location and size of each record, meaning if this is one record, then associated with this record there is a pointer, and this pointer points to some location, meaning this record is being stored at this location, right? This dotted arrow, this indicates the end of free space. So we are having in header, we are having number of records, this location, this particular arrow, dotted arrow, indicates the end of free space, and how many records we are having, those many entries we are having in block header. So every entry of such kind in block header represents the record along with a pointer that points to the record in this block. Right? Now, see here, the free space in the block is contiguous between the final entry in the header array, and this first record. Right? So if a record is inserted, then space is allocated for newly inserted record at the end of this free space. What it indicates, suppose right now I am having 4 records, and suppose I want to insert one more record in this block. So whenever we are inserting one more record in this block, then in block header we are having the entry of this record along with the pointer that will point to that particular record. Right? So this is the free space which is available for inserting new records, and this is the first record that we are having right now. So before this, now the space is being allocated according to the length of the record, and in this space now the new record can be inserted, and this pointer gets updated such that this points to this new record. Accordingly, this free space pointer also gets updated such that it is now pointing to end of this free space after inserting this new record. Okay, so this is how the record is being inserted into the block. Okay, similarly, if I want to delete a particular record, what will happen? If I want to delete, say for example, this record, I do not want to have this record, so I am going to delete this record. So while deleting this record, what happens is this space need to be freed. So this space should be added into this pool of free locations. So what happens is, if this record is being deleted, then whatever are the records, those are stored after this record, right? These records are being shifted, right? So that this free space is contiguous. We do not want any fragments, right? So records can be moved around within a block to keep them contiguous with no empty space in between them. So accordingly, the entry in the header must also be updated. Right? So if I want to delete this record, then actually I am deleting this record, and now rest of the records after that record, those can be moved within this block, so that we can maintain this free space contiguous. We do not want any free space in between. We do not want any fragmentation in the block. Accordingly, if I am deleting this record, I need to update the respective header entry also in my block header. Right? So I hope you must have understood this concept. Now, you may have a question. If we are moving the records, there must be some cost or overhead associated. But please remember, the block size is, say for example, 4 kilobytes or 8 kilobytes. Right? So, even though we are moving the records within the block, the cost of moving the records is not too high, since the size of the block is limited, that is 4 kilobytes or 8 kilobytes or something like that, depending on the operating system that we are using. Right? So even though we are moving the records, right, to eliminate the free space in between the records, right, the cost associated with this movement of records is negligible. It is not high. Right? And that is why we can have such kind of implementation to store records, multiple records in a single block. Now, one more point to be noted is the slotted page structure requires that there be no pointers that point directly to records. So pointers should not point directly to the records. Instead, they should point to the entry for the record in header. What does this mean? Suppose if I want to locate, say, a record with some key value ID, some ID, right? Then if in this block that record is stored, then it is not possible to directly point to that particular record. But whenever I am searching for this particular record, it consults first with the block header. So pointer should first point to the block header. It searches for the record in this block header, and accordingly this pointer is being traversed. So this pointer will take us to the respective record having this ID, say 10101. Right? So there is some kind of indirection. So pointers are not pointing directly to the record, but instead they are pointing to the entry for the record in header. Right? And in this header, the actual pointer is present that will take us to the required data. Right? So this is how actually the number of records are being stored in a single block. Right? So I hope you must have understood this concept. Slotted page structure to store variable length records in a single block. Okay? So with this, let us conclude this session, and in the next session we will be focusing upon the file organization techniques. Right? So let's stop today.